unpredictable. It changes rapidly. Climate is the sets of long-term behavior. So we expect to see the long-term behavior. We rarely get that, though. What we get is weather. And that was a saying from Mark Twain, of all things. He came up with that about 100 years ago. So what we're going to be talking about mostly today is climate, about the long-term changes. Well, how many people think climate is changing, both here or where you live, where you're from? We have people from all over. How many people think climate changing? Yes. Yeah? No. Well, it does change. And there's an this is the longest, the most text I have on any image. But the lesson here is that climate has changed dramatically in the past. We have overwhelming evidence. Geology, ice cores, there's a number of ways. Here in Michigan, anybody ever hear of a Petoskey stone? Have you been up, or anybody? I know some people. The state rock, of all things, of Michigan is something called a Petoskey stone. And it's a very interesting stone. They're different sizes. And if you go on holiday or you drive up to places like Traverse City in northwestern lower Michigan, you go on the lake shore and you can find these interesting rocks, and they have a very distinct pattern. And if you're close enough, you can see some of that pattern here. This is a little image of one. This is fossilized coral. And when I talk to school children and so forth, I say, well, this rock is fossilized coral. Does that seem unusual to you in Michigan? And of course the reason is, well, coral is a tropical species. It cannot survive where you have ice and snow in winter. It requires 28 degrees Celsius or higher temperatures to survive. So those coral lived here in Michigan when Michigan was actually tropical. The climate here was tropical, and it had to do with the big plate that Michigan and the Midwest are on was closer to the equator of the Earth. And it was much, much warmer. It was tropical. There was a shallow sea. So we've had tropical climate in Michigan. 15,000 years ago, where we're sitting was under 1,000 meters of ice. Huge, and in Russia too. In Russia too. Many parts of the world, but here in Michigan. So we've had both tropical and we've had glacial as well, ice, and everything in between. No question about that. And it's changed between. So climate is, humans like to think of climate as something relatively stable or unchanging, but it's anything but. It's dynamic. It changes. It has changed in the past. It will undoubtedly change again in the future as well. So that's an important idea. So climate, yes, climate does change, and there are a number of natural ways that climate changes. I just mentioned the Earth is filled, or the surface of the Earth is actually a series of big plates that literally float on the layer below them. And those plates move, which is why we have volcanoes and earthquakes when these plates move. It's called tectonics, the English word. And those plates, as they change, it moves you closer or farther away from the equator. So the climate changes as a result of that. There are minor variations in how much energy comes from the sun. Energy from the sun drives the entire climate system. That's the overwhelming source of energy, and that changes sometimes over time. How much comes? Fortunately, the sun is very, very consistent. So this doesn't have. That's not very much. But what is a little bit more is that the Earth, in its orbit, it orbits around the sun once every year, 365.25 days, and that every 10 to 20,000 years or so, that orbit, the shape of that orbit changes, and it gets a little bit closer or a little bit further away from the sun. So that orbit is not perfect. It also, the Earth sits at a 23.5 degree tilt on its axis, which is the reason we have seasons. It turns out that 23.5 degrees is not constant. It wobbles a little bit over time. And collectively, with these little minor tiny imperfections, every few tens of thousands of years, it results in a little bit more or less energy from the sun that get into the Earth's climate system. And this is thought is something called the Milankovitch theory. This is what is thought to be the natural mechanism for glacial, interglacial periods, naturally, in our climate record. That very, very tiny but still subtle change in the Earth's orbit. We can have volcanoes erupt and spew huge amounts of dust up into the second layer of the stratosphere of the atmosphere and block out some of the incoming solar radiation reflected back out to space. That's happened as recently. It happened with Mount Pinatubo. We don't have anybody from the Philippines here. But Mount Pinatubo erupted in July of 1991, and the following 2 years were at least a degree Celsius cooler as a result of that, because some of the sun's energy was reflected out by dust and ash.